In this video, we'll show you 4 common security issues to watch out for when building a web app. Before we can understand what a secure web app means, we need to understand how the internet works. What happens when a user navigates to a page on your app? Whenever a user navigates to your web app, the internet sends a bunch of information to their browser. It can be CSS files, JS files, JSON files, a lot of different files that you may not expect go from the internet, the big block of the internet, to your user's browsers. In those files, there can be a lot of data, a lot of information that you may or may not be aware of. And security is all about data. A secure web app is a web app where users can only access and edit the data that they're allowed to. With that definition in mind, there are 4 common security issues you need to watch out for. Number 1 is unrestricted user access. So this happens when anyone can see or manipulate the data. On this page, for example, we have this data that is visible on the page, but there's also a lot of data that is not displayed on the page, but visible in the browser. If we open our browser's inspector and reload the page, we are in the network tab of our browser inspector, and we see a lot of files being downloaded. So remember, there can be some JS, CSS, you'll have some font files, a lot of information. And when you go to the Fetch XHR tab in the Network tab, you can see API calls that are being made. So here, for example, the job API call. If we look at the preview, we see there are 6 items which match the 6 items we have on our page. If we open these items, we see we have a bunch of information. In the headers, we also have the URL request for these jobs. So if we copied this URL and used a tool like Postman to make the call, we would receive the same information. Now, in this case, it's not a big deal. It's a list of jobs, and we're more than happy for people to be able to access these jobs. We're happy for people to be able to view these listings and potentially apply to them. However, REST APIs are usually pretty standard. So we could guess that if we changed the GET request to a POST request and passed the ID of a job, maybe we could change that job in the backend. We could try it. Let's see what our backend looks like. In our database, the job with ID 1 is a senior Angular developer position in San Francisco. If I go to Postman and make that request, it looks like it worked. I have a status code 200. And if I go back to my database, I refresh, and there you go. I replaced the information with nothing. I could replace it with incorrect data. So in the parameters, I could say that the title is I hacked you. There you go. And then on my web app, now I see that my data has been compromised. There's a very quick fix for this, is on the endpoint that allows users to edit a job, we could protect that endpoint and enable authentication. So now users need to be authenticated to make that call. And if I go back to Postman and try to change this again, I have to again try this. Now I get an error. I am not authorized to make that call. And if I go back to my database in Xano, if I refresh it, I don't have the I hacked you again message. So this is how you would protect an API endpoint. Another option would be to protect a table. If you're working with a no-code backend like Supabase, you can add row-level security policies and define what users can do with this table. So for example, our list of vehicles, this is a car rental project. Our list of vehicles, there's no row-level security. Everyone can do whatever they want with this, which is not ideal. But our user roles table, we have enabled row level security and we have 2 active policies. Everyone can read the roles, but only authenticated users can change a role. The key takeaway here is that some actions should not be allowed if a user is not authenticated. You can define this user restriction at API level or at table level. If you're working with a backend tool like Xano, it will happen at API level. If you're working with a backend tool like Supabase, it would be at table level. Another common security issues is when people filter data in the front end, mistakenly thinking that because data is not displayed on the page, it is not visible or accessible by the user. Here we added authentication, so there is no data when the user is not connected. However, if I log in, now I am logged in, I get these 2 user applications. I get my user applications. In WeWeb, if I go on the container, I can see that I fetched all user applications and used the filter by key formula to only display 2 objects. So based on the user ID of the person who is authenticated, I filtered the correct applications. However, if I look at my network tab in the browser's inspector, I can see the API call to get the applications. And if I look at the answers here, I see I have more job applications. I have 9 in total from 0 to 8. And if I open these job applications, suddenly I get private data, maro@email.com. So this is not my job application, and I have access to information from other people, which is a big no-no. I should not be able to access private information from other users. In this case, I can go to my endpoint and add the filter at backend level. So here in Xano, I will add a condition where the user ID of the person who applied is the same as the ID of the person who is authenticated. This will not always look the same depending on which tool you're using. What is important to remember is you are adding a filter so that only the information from the authenticated user is sent back to the front end. So here, our backend will only send the 2 items that are related to my applications, to my user ID. And if I publish this change, and refresh the page in WeWeb, I now only have 2 items, which are my own. The key takeaway here is that you should always filter sensitive data in the backend. You should never trust the front end to hide information. Any information, any data that is sent by the backend, by an API to the front end is potentially accessible. The third common security issue to watch out for when building your web app is horizontal escalation of privileges. What does that mean? It's when a user can pretend to be another user. Here, for example, the user is authenticated. We have ensured that the user needs to be authenticated to access their applications. The backend is only sending the current user's applications, so that's good. However, in the headers, I can see again the URL that is helping me get my own information, my own application. So I can guess that if I use a similar call in Postman, this time changing to delete, I might be able to delete a bunch of applications that aren't mine. So here I would delete my own application, which I wouldn't want to, but let's say I wanted to delete applications of other people because I want a better chance of getting the job. Then I could randomly delete a bunch of applications. I would do it randomly so it's not obvious that I'm deleting all the applications except mine, but I could really set up an automation to make a lot of API calls that delete those applications. Let's see in our database. Here I have application 22. So I'm going to attempt to delete application 22. Let's see. Unauthorized authentication required. Not a problem, because if I go in my header here, I can find my bearer token. I will copy my bearer token and add it in my call. Bearer. Now let's try again. Seems to have worked. I have status 200. Let's refresh my database. Will this record disappear when I refresh? Yes, it will. So in order to protect my table, to avoid a user deleting another user's applications, I can go to my API endpoint where I delete an application. And here, before agreeing to delete the application based on an application ID, I will get the application itself based on the input value. And then I will add a precondition to make sure that the user ID in my application one variable is the same as the user ID of the person who is authenticated. Let me save this. I will add a message saying, you're not allowed to do that. And say access denied, and save this. And I need my condition to happen before I need my control access to happen before I get the record from the application, or sorry, before I delete my application. So first I get the record from the application. It returns a variable called application_1. In this output, I can customize this output, in fact, and get only the user ID. I don't need any other information. And now I am checking that the user ID in this variable matches the user ID of the person who is authenticated. And if it doesn't match, I will return an access denied error. If it does match, I will agree to delete the application. So let's publish these changes. Create a new fake application, 24. And in Postman, let's try making that call again. Error code, access denied. You're not allowed to do that. You get a 4.3 forbidden. The error message may depend on your backend. You can define the message and the payload you want to return in your backend. You decide. And here we did it in Xano at endpoint level. In Supabase, you could have a policy where you can fully customize how it works. It's SQL, it's a bit more no code, but the idea is if you're working with a backend that allows you to protect your API endpoints, protect those API endpoints. If you're working with a backend that allows you to protect your tables directly, protect those tables. The key takeaway here is that requiring a user to be authenticated is not enough. You also need to add control access checks to ensure that a user cannot modify another user's information unless you specifically want to give them permission because they have an admin role, for example. Which brings us nicely to the fourth common security issue to watch out for when building your web app: vertical escalation of privileges. This happens when a user who doesn't have an admin role is able to make themselves an admin. In other words, a user who doesn't have the permission to do something finds a way to give themselves those permissions. Here, we're logged in as a common user. We are not an admin. But here, we managed to access a page where we can edit our role. So I can make myself an admin and validate this. Now, let's see what happens in my database. Here I have the common role. What happens if I refresh? I am now an admin. This is awesome because since I'm an admin, I can be pretty sure that I can do everything I want in the app now. So the first point of failure, the first point of security failure of a web app is this endpoint that allows a user to change the role of another user. You need to make absolutely sure that that endpoint is protected to the maximum. There are several ways you could do this. We recommend, especially if you're starting out, to create a dedicated endpoint for admins only. So here we would have an endpoint where we require authentication and you can delete the role of a user, and then when the user makes the call, you get the record from that user first. Then you check that their role is admin. And if they are indeed an admin, they are allowed to edit the role of a user, including themselves. In WeWeb, that would mean on our data grid, instead of calling this post/user/user ID endpoint, we would call the post/user ID/admin endpoint. The user ID would be from our data grid and the role as well. Now, let me change back to a common role here. and refetch my collection. So I'm common again. And now if I try to edit this to admin, oops, admin, open this. If I validate this, I will get an error of 403 telling me access denied. Whoa, whoa, whoa. The key takeaway here is that you want to pay special attention to any API call that allows a user to change roles or permissions. You really only want admins or super admins to be able to do that. There are several ways you could approach this. You could have one API call to update a user, and depending on if someone is trying to update the role or not, check if the user is an admin or not. When you're first starting up, we would recommend having a dedicated endpoint for anything sensitive. It will be easier for you to maintain, to get a clear idea of what is going on and where. As you grow in confidence, you can build more complex endpoints and have only one endpoint to maintain. But to get started, we recommend keeping things separate so it's easier to see where you might have a security vulnerability. So let's recap what we talked about. We said that when a user accessed an app in a browser, the internet sent back a bunch of files. Then we said, careful, inside those files, there can be data that you didn't realize was going into your user's browsers. To protect that data, to ensure that only the needed information is sent by the backend to the front end, you need to either protect your API endpoints or your database tables. This will depend on the backend you're using. Xano, for instance, the security happens at API level. Supabase happens at table level. 4 key takeaways. Ask users to be authenticated to perform certain actions. Add control access checks if you need to, so that a user cannot modify another user's information unless they have the right to do so. Use dedicated endpoints for admins, at least when you're starting out. That will help you see more clearly where you might have a security vulnerability. And finally, make sure to filter sensitive data in the backend. If there's one thing to remember out of all of this, is that you should never trust the front end. This is not specific to WeWeb. You should never ever trust the front end, even if you're hard coding your web app. Not even conditional rendering, not even private pages. You can make a page private. So on our page where users can update their role, we said that only authenticated users with the role admin can access that page. That is a nice thing to have, but security still happens in the backend. The endpoint, the table should still be protected at backend level. That's it. Those are 4 common security issues we highly recommend you look into when building your web app. If you're working in a backend like Xano where you can protect API endpoints, we highly recommend that you go through all your endpoints and ensure that you have authentication, filters, and control access checks properly set up. If you're working with a backend like Supabase that enables you to protect tables, we recommend that you go through all your tables and review the security policies you have there to ensure that people need to be authenticated, that the data is filtered properly, and that you have the proper control access checks in place.